So part of why I wanted this talk is I got to see it the first time Kenny gave a version of it, which was the first Docker meetup that they held at the new Docker headquarters. Did you turn your mic back on?
I just did, yeah.
Yeah, and what I really like about this is it's whimsical and fun, but also technical and informative. So give it up for Kenny Bastani.
Thank you, Bridget. Hey everyone, how's it going? Good? You guys get plenty of good drinks, take advantage of that situation, open bar, right? Good deal. Okay, so my name's Kenny Bastani. Today we're going to be talking about graph processing with Spring Cloud, Docker, and Apache Spark, and about a billion other tools as well that are really interesting. A little bit about myself. I work at Pivotal on the Spring team. I'm a Spring developer advocate. I work with Casey and Bridget and many more awesome evangelists. I'm writing a book called Cloud Native Java from O'Reilly. So this is all about building microservices, SJVM applications using Spring Boot, Spring Cloud, and Cloud Foundry. Today we're not going to be talking a lot about Cloud Foundry. Really, this talk is completely a toy project of mine, just a passion project. I used to work at Neo4j as a developer evangelist, and I created a couple community projects to do graph processing, graph analytics, using Apache Spark. So this is really just a toy project of mine. So what it does is it ranks Twitter profiles. So on Twitter, it's going to import all these Twitter profiles. What I'm going to do is I'm going to choose a couple seed profiles, 3 users who I want to understand what the community around these users is composed of. And that's the basic idea behind this. So this all has to do with PageRank. Raise your hand if you've heard of PageRank, used PageRank, know what PageRank is. Wonderful. So PageRank was created by the founders of Google, specifically Larry Page. And Larry Page wrote, he has an abstract here where he explains what PageRank does. I'm just going to read it verbatim. So the reason that PageRank is interesting is that there are many cases where simple citation counting does not correspond to our common sense notion of importance. For example, if a web page has a link to the Yahoo homepage, it may just be one link, but it's a very important one. This page should be ranked higher than many pages with more links, but from obscure places. PageRank is an attempt to see how good of an approximation to importance can be obtained from the link structure alone. So the idea here is that I have the shape of data, and I'm able to actually figure out what the importance of a certain node or a data point is just based off of the shape of the graph. I don't care what the data points are, just the connections between them. So here we have an example. I'm going to awkwardly try and do this with a pointer. So here we have an example of a graph, and here we see that B is the most important node in this graph. And why is that? Well, we see that we have a distribution of links incoming and outgoing for all these nodes, all these vertices. And we can see that, of course, that B has the most incoming relationships, and that's probably why it's so big. But we also see that C is very large, but it only has one incoming relationship. So the idea here is that PageRank is going to, in a series of stages, produce the importance relative to the rest of the graph just by assigning a vote. And every time that it has a stage, a subsequent stage, it's going to assign a greater weight to each vote until it's hit convergence, until it's settled. And that's why we have C as the second largest vertex in this graph. So the idea here is that I wanted to take this very same idea, use this graph analytics plugin that I created for Neo4j, and to create a ranking dashboard using Spring Cloud specifically. So the idea here is that I'm going to have 3 users that I choose. And so this is Twitter profiles. And so I've plugged in myself here. I plugged in Adam Herzog, who's community manager at Docker, who used to work at Neo4j. And then Nicole White, who is currently an evangelist or data scientist at Neo4j. And after that, I'm going to import a series of users. This is after about an hour of imports and ranking. And so we can see here a couple features of this ranking dashboard that's produced. So we have, of course, the profile information. And then we have the following count as well as the followers count. So we can see exactly what's the difference between their followers and following count. Also, we get our PageRank value. This is calculated by Apache Spark. And then we can see after every step, every time we run this analysis, what's the change in the ranking. And so after a while, so what I noticed when I did this project was that it came up with a pretty strikingly interesting graph for a community of people that were very much related to the profiles that I chose. And it just was like an inherent feature of this kind of algorithm. So all of these people that I have here that have the plus signs next to them, those are very important connections to myself, Adam, and Nicole. Emil, he's the CEO of Neo4j. Mark, these are all Neo4j people. So that was that was one of the first tests that I ran. So after a while, this was after about, I think, a day, it became, we got a closer and closer approximation of importance for the community. And it really surfaced like all of the community members that were talking about Neo4j on Twitter. And that was very interesting. So I came up with this little project, so I'm gonna demo it to you and show you how it works. The tools we're gonna be talking about: Spring Boot, Neo4j, Apache Spark, Docker, RabbitMQ, and I even threw in a tool called Weaveworks. Who's heard of Weaveworks? Really? Oh, you guys are gonna love this. This is really cool. I'm excited about it. So I'm actually gonna show you how this application looks running. I have it running on AWS, and so I'll just refresh this. So I started this about a couple hours ago, and I added myself Casey. Come on, okay. So I added myself, added Casey, and Bridget. So I just wanted to see exactly what was going to get pulled in over time. And so what I have here is a ranking dashboard that's been up for about, I don't know, an hour or two. So it's just about at 100 users. So we can actually check on this dashboard where Casey is. So Casey's at number 82. One of the things I should mention here is that it's going to pick users that are high value in this approximation. So naturally, myself, Bridget, and Casey are going to move down on the ranking dashboard. But yeah, so Casey's here at 82. I'm at 74, and then Bridget is at 54. So Bridget's doing pretty well. And so that's just the basic idea. So over time, this is going to add more users. It's going to discover more users from the community. We can see that Pivotal's here, of course. Now, this really doesn't give us a good understanding of, over time, the users that were discovered. So I created a query here. This is Neo4j, by the way. That's going to tell me exactly, in order, starting from those seeds, who was discovered over time. So I'm just going to run this query real quick, and we'll go over Neo4j more later. But just to kind of show you the relevance here, this is the first 10 users. So starting with myself, then Casey, and then Bridget, these are the users that I've added. Then the next one is Josh Long. He's my co-author on the book Cloud Native Java. He's also on our team at Pivotal. Julie Kuntz works at Pivotal. She's a rep in DC. Dr. Nick is huge in the Cloud Foundry community. James Waters, he's one of the vice presidents at Pivotal. Then we have Bad Nima. This is our chief of staff at Pivotal. Then Josh McKenty, very well known in the community, also at Pivotal. My boss, Andrew Clay Schaefer, and then Matt Stein. So this was the path, the progression that this algorithm chose over time. Now, it's choosing from a huge set of data. So the interesting thing here is that it was able to pick out these users who were very, very relevant to these 3 seed users. And that's the power behind something like PageRank. And so what I've done is really commoditize that into a platform that we can use to easily create these kinds of applications. So how does it work? So here's the architecture behind it. And I'm just going to briefly explain all of these containers. So these are each Docker containers and also Spring Boot applications that are running inside these containers. So the magic really is all in this middle application here. That's called the Twitter crawler. Now, what this application is responsible for is to actually expose resources from the graph database, the Neo4j database, and also run analytics using Apache Spark. And you can see here that we have a couple containers that are doing integration. So I have HDFS, and I have a messaging broker called RabbitMQ. So we're going to go over more about this component here, these 4 containers. But the basic architecture is that I have my backend that's going to expose a REST API, and it's also going to schedule and dispatch new jobs to import users from the Twitter API. Then I'm going to have a front end that's completely separated as a microservice that's going to integrate with this Twitter crawler just to show the front end that I just showed you. And then I have some cloud native application pieces. I have a discovery service, which is using Spring Cloud Eureka, and then I have a configuration service that's allowing these applications to load in configurations when they're deployed to an environment. So let's talk about how this is done. So starting out with what I like to call a graph processing platform. this is one of the critical pieces of this kind of architecture. So I have these 4 containers, and this is going to give me the ability to store data as a graph, right? I've chosen a graph database because it's really the best kind of model for the problem that I'm trying to solve here. If I want to run PageRank on a graph, I can store that as a graph. I don't have to do any translation of data. And so what I'm going to do here is actually, from Neo4j, I'm going to have to submit a job, which is going to put a new message on RabbitMQ, as well as export a representation just of the shape of the data to HDFS. Then Apache Spark is going to pick up that new job from RabbitMQ, and it's going to load in that data from HDFS, and it's going to apply the analysis, the PageRank analysis. So kind of breaking that down step by step, what that looks like here is that we'll have Neo4j submit a new job request, and that job request simply has 2 pieces of information. The path on HDFS, where it's exported that data set, as well as the type of job that it should run, so the type of analytical job that it should run on Apache Spark. And so what that looks like is when I export this graph representation from Neo4j to HDFS, this could be millions of nodes and relationships. What I'm going to do is I'm just going to specify that I want this to be formatted just in a 2-column CSV. And so the first column is going to be the node that has a relationship outgoing to another node, and the second one is the incoming relationship. So I can encode this entire graph here just in this representation of the edge list. So this is actually exactly the representation here of this graph. So now what I need to do is I need to import that HDFS file into Apache Spark and then run the analysis on that. So very simply, I'll take that in from Apache Spark. The reason why I'm using HDFS here is that HDFS allows me to store a data set in blocks of 32 to 64 megabytes. And so Apache Spark is going to be able to load those blocks in and replicate them across the cluster in memory and then do the analysis on them. So that makes it very efficient. And so what it's going to do is just load that representation in. It's going to run its analysis, and after it's done, it's going to export a result set back to HDFS. So it's going to use HDFS as this transfer layer where it's just storing the file intermediately before either Neo4j or Apache Spark picks it up. And so the idea here is I want to put that data back in the database, because if I'm able to put it back in the database, then I can just query the database itself, and I don't have to worry about working with Apache Spark at all. All I have to do is work with the Neo4j graph database, put my data in it, run the analysis, and get the data out. And that's all I have to worry about. So what it's going to do is it's going to save this result set back to HDFS with the ID of the node or object that it wants to, that it has the result applied to it, and then the PageRank value itself. So we see here node 0 in the graph has 0.56. And so that's the basic idea here. We're going to have this 2-way ETL process where I import data in Neo4j, I run the analysis, Apache Spark is going to pick up a job, it's going to apply that back to the Neo4j graph database. It's very simple. And so now what I'm going to do is I'm going to demo exactly how this works using Docker Compose. And so what I did was to not worry about the network concerns. I went ahead and I deployed a couple AWS VMs and preloaded them with Docker Compose to show you how this works. So I'm just going to SSH into this VM. And what I have here is a Docker Compose file. So we'll just go over that real quick. So this is just for the graph processing platform. So this isn't all the containers. This is just the containers that have to do with the graph processing. So we see here the first container is HDFS. Can you guys see that? Yeah, that's fine. HDFS. So that's just going to use this Hadoop Docker image. I didn't create this. It already exists, so I'm going to use that. I did create this container called Maze Runner, and this is going to actually bundle Apache Spark with RabbitMQ, and this is going to be used to actually pick up the jobs and then run the analysis. And you can see here that I'm linking to HDFS. Then I have Neo4j, which is my graph database, and I'm going to actually create this container as well. And this is just going to contain Neo4j, and it also is going to have this extension that I created, because I had to customize Neo4j slightly to be able to do this. And so that's what's inside this container. And we can see that I'm exposing that on ports 7474 as well as 1337. I'm also mounting it to the host volume here with opt and then data. And then I've also created a couple links back to the Maze Runner container as well as HDFS. Now here's the cool thing. So I recently added this. This was a pull request to one of my projects by Weaveworks. And all this does is it adds in another container which contains the Weaveworks product. And what this is it's like visualization for your containers and how they're connected, which is quite interesting. I'll show you that in a second. Now, if I back out of this, we can see with Docker Compose, let's see, PS. I already have these running. So what I'll do is actually, I'm just going to shut this down and show you how it works from scratch. This might take a second. Any second now. I should have just killed them all. I have a joke while this is going. So the joke is, who's a database person in here? Do they consider themselves a database person? Anyone? Great. Okay, so the joke is, why did the database have problems ingesting data? If you get this right, I'll give you a book or a t-shirt or something. Okay, ready? So it had acid reflux. Acid reflux, get it? Yeah. Takes a second, but it's good. Okay, so now that I've told my joke, let's remove these and then restart them. So now I'm just removing those containers, making sure that they're fresh. All right, so then I'm going to do Docker Compose up and then D, which is going to detach the command line from the process. So I run that, and then I can see that they're starting. And then I'm going to go ahead and do Docker Compose logs. Oops. And I'm going to want to, yeah, so we can see that they're starting up. So what I'm going to do here is I'm going to go to Weaveworks, which I have running. Let's see if that works. And so now this is the product. This is the one container that was added to just those other three containers. And what it does is it's going to show me exactly how these containers are networked. And I can actually even just exit from this SSH. This was the cool thing that I discovered is I don't even need to. I used to do this demo. I just tailed the logs from that. From the SSH. What I'm going to do here is I'm going to show you this through Weaveworks. So I'll go to the Maze Runner container here. Now this is where Apache Spark is running, so we're going to be able to see when PageRank is run. So I'll open that, and then in another window, I'm going to open up the Neo4j database, and I'm just going to attach to the logs. Okay, so now that those are up, we see no logs. What I'm going to do is I'm going to show you how this works from the database itself. So here's Neo4j. It's a graph database. It allows you to store data as a connected graph. And what I'm going to do here is I'm going to load in a movie graph. This comes with Neo4j. And this is just a graph of like an IMDb data set with actors who acted in a movie or people who directed a movie. So we can see here that we have Tom Hanks. And Tom Hanks has acted with various other he acted in various movies in green, who also we see here on the other side of the graph, we have actors who either directed those same movies. So we have a connected graph here that we can run some analytics on. And what I'm going to do here is I'm going to run PageRank on this graph, but in order to do that, I need to first extend this graph. So here this query is match, this is called Cipher. What I'm going to do here is I'm going to match this pattern. This is going to give me all of the people who acted in a movie and get me the people that they acted with. So I'm going to get co-actors of the movie, and then I'm going to create a direct relationship between them called Nose, and this is going to allow me to run PageRank on that Nose relationship and find who's the most important actor in Hollywood to work with. So I'll go ahead and run that query. So now we can see that 768 relationships were connected. I actually can go and query that, so I'll do person, Nose, PA limit 30. And so now we can see this result set. So what I've done is I've just queried a sample of this graph so we can see this big furball here has the nose relationships. And so now I have a pretty good representation of the amount of times that people in this graph have acted with another actor in a movie. I can actually go ahead and run PageRank on this to get the results. So what I'll do here is I will, from the command line, use my Maze Runner plugin, which is going to be this URL here. So relative path / service Maze Runner, and then the analysis type is going to be PageRank. And I specify here that I only want to process the relationships that our type knows. So if I go ahead and run this, we see that it's success. And I'll go back to Weaveworks, and we can see that this is the flurry of output that's happening in that container. So this is Apache Spark actually outputting the steps. As it's analyzing this graph, it's outputting each step. It's showing exactly how it's replicating each of the blocks that are in the data set, and then it's running PageRank in stages. And so when this finished, we can see back in the Neo4j container, we had sent the request to Apache Spark. So here's the message that was sent to RabbitMQ. And then we see that it received a response back to import from this URL here. So that's the basic idea. So that very simple interface, I've just plugged it into a Twitter crawler application that is going to schedule jobs to import users and then run analysis on those users. Okay, so now let's talk about building microservices a little bit. So now I chose to create this architecture because I wanted to come up with something that really resembled a microservice architecture so people can kind of start playing with these types of architectures. And I think Docker was a good fit here to make this a demo. So this Twitter crawler application is the one we're going to go over first. We're going to go over each one. So each one of these hexagons we'll go over. So the Twitter crawler service is the most important one, and that's going to contain really a data model, a domain model rather, for our users and their connections to other users on Twitter. And so I used Spring Data Neo4j repositories to do this. Who's using Spring Boot or using Spring at all? So who's not using Spring? Just checking. Okay. So in between there, I don't know. Okay, so let's talk about how I built this application then. So I used Spring to do this, and I created repositories. So I started out by creating a user repository. That's going to allow me to interact and manage these user records. I also created a follows repository. That's going to allow me to create relationships between users. So remember, the process here is that I want to import users from Twitter, and then I need to interact using these domain objects to actually import them into Neo4j. So this is really going to be the controller that handles that process. So I need these two repositories, the user repository and the follows repository. And then what I've done too is we saw a little bit of Cypher. I've mapped custom Cypher queries to repository methods, custom repository methods, and I've turned them into REST APIs. So we'll look at that in a little bit. So the domain model is pretty simple. We have a user, which is going to be one node in the graph, and then the follows relationship, which is going to connect the users together. So where we're going to start here is we're going to look at our domain model. So this is the domain model that we're going to take and create these repositories from. So it's a very simple domain model. We have users, and we have relationships between them, which are follows. So we can see here in the center, this is myself. We can see just a little bit of the property information that's going to be assigned to this Pojo. We also see Star Buxman. He's Josh Long, who's on my team at Pivotal, and we also see Bridget. So very simply, this is the model that we're going to use to create these new Pojos and interact with that data using the repositories. I don't know if you guys can see that, so actually let me, yeah, I gotta zoom in a little bit. Okay, so here's the code for, this is the user Pojo. And very simply, this is just a collection of fields and then getters and setters. So right here I have the annotation node entity. That's going to define this user Pojo as an object that we're going to be able to manage with our Neo4j repositories. Then I have my primary key here. That's my ID, and I'm going to annotate that as graph ID. Then I'm going to have a profile ID, which is unique to each user because this is how Twitter is going to track these uniquely. Now, we're going to generate this ID here. That's going to be used internally. It's important, but this is the profile ID that never changes for any of the users, and that's going to be important later. I'm also going to create the follows and followers property here. This field is going to allow me to pull in all of the users that this user follows or is being followed by. And so I'm going to use these annotations called relationship to do that. And then just the rest of the properties that we're going to import from Twitter. So the other object here we need to create is the follows object, and that's going to be very similar to the user pojo, but much simpler. So here at the top we have relationship entity instead of node entity, and then I'm going to specify that this should be the type follows. Then I'm going to have my unique graph ID. This will be the ID of each relationship. And very simply, I have a directed relationship between a start node and an end node. So we have user A and user B. So when I import from Twitter, I'm going to create a collection of these relationships. I'll batch import them into Neo4j. And so I talked about extending this user repository using Cypher. So what I can do here is I can extend the REST API just by using a query annotation. And so this match query, this is just one of many that I've added. This is going to allow me to get a user by their profile ID and then to return back the unique ID that's being used by Neo4j. And so that's just one example. So this one is, I don't even know. This is safe. Oh, this is very important. OK, so this is one of the most important queries in the repository. And why is that? So if you have to imagine this scheduled every 5 minutes, whatever, I'm pulling in users from Twitter. Twitter's a massive data set. Now, I really have to worry about transactions when it comes to how I import this data into Neo4j. So if I'm going to import 1 million users, I'm going to need to batch that into chunks. And so what this query essentially does is it allows me to save a collection of follows relationships, and I'm using a Cypher query here to batch import them. So every time I import 5,000 users from Twitter, I'm going to use this method here to save those users in a very performant way. Otherwise, it's going to completely kill the database, and it's going to be very bad for us. So that's about it. So I have my Spring Data repositories here. Now I can actually interact with this data using Java. So that's very good. So the very simple thing that I'm going to do here is to add in a REST repository. So I'm going to add in just one dependency here with Spring Boot, which is called Spring Boot Starter Data REST. And this is going to allow me to really just take this repository that I just created and turn it into a REST API without any additional work whatsoever. So we don't have to do any manual effort to actually turn this into a REST API. It's just going to be one dependency that we add, and it's going to be done automatically. So this is Hypermedia. Who's heard of Hypermedia? Just raise, yeah, great. So Hypermedia is going to return a set of links back. These links are going to tell me exactly how I can traverse my REST API. And so we can see here the repositories that I've added. So I've added the following repository and the user repository. And so I can actually go to these repositories and access them via the REST API. So if I go over to my Twitter crawler, sorry, this is the UI, the front end. Now, I know where this is. It's at 8080. So if I change the URL here to 8080, I'm going to be able to see that I get back a response that's JSON. So I'm actually going to open up this in Chrome. OK, so here we have, this is on AWS. Here's my repositories. I actually added another one here. That was bad. But we have the following repository, and we have the user repository. So I can actually go to /users, and this is going to give me another response, which will probably time out because there's a ton of users in here. But I have another endpoint in here, which is /users and then /search. And this is going to give me all of the repository methods that I've created that are custom. So here I can use these methods to find users. So we looked at earlier for the follows. Oops, follow. Which one is it? Following. Following. Right. So here's the method here for save follows. And so the basic idea behind this is that I can very simply create these repositories as objects in Java, add in one dependency, and they can be created as a REST API. Now I can use this in a microservice architecture so that my front end is just going to be able to consume these REST API endpoints. And it's going to use Spring Cloud to do that. So if we look back at this diagram, what we've gone over is just the Twitter crawler data layer. And so what we're doing here now is that the ranking dashboard is going to communicate with the Twitter crawler, and it's going to embed into its own application a list of all of the endpoints that are available on the Twitter crawler. And it's going to reverse proxy. But that means that we're going to call within our own host to the Twitter crawler service, and we don't even have to worry about any code that we need to add to this project to be able to do that. So if I go back to the ranking dashboard, now, since this is all client-side JavaScript and HTML, I need a way to contact those REST APIs in that microservice from JavaScript. And so to do that, if I go to /routes, we're using something called Spring Cloud Zool to be able to do this, which is going to embed the Twitter crawler's API into this actual application. So now we can go to Twitter rank, and I'm going to be able to see, as a part of this host, the response that we saw, exact response that we saw from the other application. And so now I can actually interact with that data without even having to make any application calls. So it's very useful. OK, so the next part is I want to connect into the Twitter API to start importing users. So we have this integration piece. So this is all using Spring. So the next dependency that I'll add is the Spring Social Twitter dependency. And this project is going to give us the ability to just have a very simple Twitter client to interact with records on Twitter's API. So the first thing I need to do is to configure this. And so what I'll do is in my application properties for this app, I'm going to add in Spring Social Twitter and then my access tokens as well as my secrets. So what I'm going to do with the configuration service is I'm going to just externalize these. I'm going to inject them into the container itself when I deploy the application. So I'm not going to actually build this as a part of the app itself. Then what I'm going to do is when I configure this, this client here, which is called Twitter template, I'm going to map these values from the configuration to properties. So we have app ID, app secret, access token, and then access token secret. And so the benefit here is that I can just inject these as environment variables into the container itself. I don't actually have to build these as a part of my project. So the next thing that we need to do is to actually connect into the Twitter API. And so with Spring Social Twitter, I'll get a collection of different methods that I can use. This one here is just an example of creating a client to actually listen for jobs and then perform some operations. So here I have the find followers method. And so I'm just calling the Twitter template here and using friend operations and then getting a list of follower IDs for a profile. So what I'll do here is just get a list of IDs from my followers instead of importing all of the user data all at once. And I'll use this to gradually expand this graph over time. So the next step here is that I want to schedule new PageRank jobs. So we're going back to this idea of this graph processing platform where we have this workflow that's going back and forth between Apache Spark and Neo4j. So before I do that, I'm going to go back to Weaveworks, and we're going to actually look at what this full application looks like. So here's the Weave scope visualization for this application. So we can see that I have all of my containers, including Neo4j and Apache Spark and HDFS. But I also have in my other components like discovery and the configuration server, as well as my dashboard. And so what I want to look at here is the crawler container, and I'm going to just observe the log output. So over time, what's going to happen here is we're going to see output from this container as it schedules new jobs. So we'll go back to the presentation and come back and take a look at this. But roughly every 15 minutes, it's going to schedule a new PageRank job. So on a 5-minute interval, I'm actually going to import new users from Twitter. But I have this constraint, which is that Twitter isn't going to let me import all the data that I want. So I have to worry about rate limiting. That is, if I call the Twitter API too often, it's going to prevent me from submitting new requests. So I need a durable way to do this. So I have two schedulers. I have the PageRank scheduler, that's going to happen on 15-minute intervals. And then I have the scheduler, which is going to discover new users and import. So as a part of this workflow here, when this is triggered, I'm going to use this annotation called scheduled. Now this is a part of Spring, and this is going to allow me to actually run this method on a fixed interval every 15 minutes. And then I'm going to call that path in Neo4j, which I showed you earlier, which is going to trigger a PageRank analysis on follows relationships in the graph. And I'm just simply going to use this REST template. This is just a basic REST client to call that endpoint after I provided the Neo4j server URL, and then just to log out that the PageRank was scheduled on the follows graph, very simply. Now, if we're lucky, we should see some output. Yeah. So now we can actually see output from that container because about every 5 minutes, it's going to attempt to import new users. Now, this is a very ugly exception, but the one thing we need to take a look at here is just the rate limit was exceeded. So this is showing you that it's not possible to really import all the data that it wants. And how I handled this was to use, again, RabbitMQ. And every time that something failed, it exports a new message to a queue of where its last point of importing a user was, so the user's relationship, and then it's just going to keep retrying until it's able to actually get a response back from the Twitter API. And then when it does, it can acknowledge that that message was received, and it can continue to submit new requests. And so that's the very basic idea. Okay, so last part of this is the ranking dashboard. That is that one to the right. And this is the most simple application in this application, this platform. Here we have just one application class with annotations. This is a Spring Cloud application. I've also added an annotation called Enable Zool Proxy. So to get that feature of being able to see the routes of an application without having to actually make calls manually to a backend, it's going to embed automatically using this discovery service all of the REST API calls from all of the applications running in the cluster. And I don't have to put any other code in this application. All I have to do is just make some configuration changes here, specify where that discovery service is located, and that's just the host name of the container, and some information of how it can be contacted. Then I just put in my static JavaScript and HTML. So what we're seeing as part of that front end is very basically in the static directory under assets, CSS, et cetera, et cetera. So here in my JS, I have my main JS file. That's where I have my calls to my REST API. And then the index.html, that's where we're seeing the front end. And so that's basically it. Sorry for running through this so fast. Actually, Casey, Bridget, and I, or no, Casey and I and Fred, we're on a world tour, which is 25 cities in 2 months. And so we're just hopping around the world, giving talks all over the place, and also still working on a book. So I want to go back to the hotel and sleep very much. So I thank all of you for coming today. If you do have questions, I will be around for a little bit. And here's my contact information. I'll just take questions quickly before I let you guys go. Any questions? Cool. Well, thank you guys very much. Appreciate it.